everyone! My name is Madison and I work in the paper conservation department at LACMA. We paper conservators take care of LACMA's works of art on paper, including drawings, prints, books, photographs, and more. Today I want to share with you a bit about the history and science of papermaking and show you a fun craft where you can cast your own small pieces of paper like this at home. I also will show you how paper conservators can use a very similar technique to fill losses in works of art on paper. So let's get started. Paper is a key part of our everyday lives now, but this wasn't always the case. Papermaking was invented in China around the 1st century CE and took over 1,000 years to travel through the Middle East to European cultures. Before this, papyrus or animal skins were used for writing, and books were rare and precious commodities. By the early Renaissance period, European paper mills were producing quality papers from plant fibers and water on handmade papermaking screens. Though our commercial papers of the modern age have evolved into something much different than these antique papers, the concepts are still the same. Paper is created by casting a pulp slurry of water and natural fibers, typically from plants, onto a screen, then drying the sheet to remove the water. Wet pulp becomes a sheet of paper through interlocking fibers and the magic of hydrogen bonding. The plant fibers used in paper are made up of two types of polymers, or molecules made in a series of connected units, like a train. These polymers are cellulose and hemicellulose. You may have heard of cellulose before. It's the building block of all living plants, from grasses to trees to vegetables. Cellulose and hemicellulose are polysaccharides, which means they're formed from many simple sugars, or saccharides. You've probably heard of carbohydrates in relation to food and nutritional facts. Well, polysaccharides are just one type of carbohydrate. Cellulose molecules have really long chains of these simple sugars, which you can see here. Hemicellulose is also a polysaccharide, but it's much shorter and has a branched shape. So if cellulose is really long and hemicellulose is much shorter and branched, which do you think would make a stronger sheet of paper? Well, you may have guessed it, but the answer is cellulose. The most important polymer for papermaking is cellulose, and good quality papers like the ones artists often choose have a very high cellulose content. Cellulose molecules are made with lots of oxygen and hydrogen sticking up all down the length of their long chains. When cellulose is mixed with water, or H2O, these elements link together in what are called hydrogen bonds. This happens when the hydrogen and oxygen are attracted to one another and make bridges that help connect the water to the cellulose and the cellulose to itself. As the paper dries and water is removed, hydrogen bonds between water and cellulose are gradually replaced between hydrogen bonds between the cellulose molecules themselves. This results in a dry and strong piece of paper made up of an interconnected web of plant fibers. Industrial papermaking is pretty complex today, involving lots of specialized machinery. But we can make our own samples of paper at home using some materials that you probably have already around your house. I'll walk you through the basics of casting your own small pieces of paper at home, including scrap paper, water, a blender, and a sponge. You'll also need some other materials for the activity, but you can definitely get creative with substitutes if you don't have one of these items already. The first step to making paper is sourcing your natural fibers. Centuries ago, plants or old clothing and textiles were soaked and beaten before turning them into paper pulp. But we don't need to do that in order to make paper in this activity. You can use scrap paper at home to reblend the fibers into a new pulp slurry. Find some papers you'd like to use. Glossy magazine paper can work, but other uncoated papers are better for this activity. Try finding papers of a similar color to make different slurries for different colored paper samples. Cut or tear your scrap papers into tiny pieces and let them soak for a long time in water, at least a few hours, but preferably overnight. Use lots of water. When the paper is done soaking, get some help to blend it in a blender until all of the pieces are chopped up into a smooth blend of tiny paper fibers. This is your slurry. Now, instead of using this slurry of fibers and water to cast a sheet of paper on a papermaking screen, we can use materials at home to simulate the same action on a much smaller scale. Find a plastic container like a water bottle or takeout container. This will be your pulp reservoir. Have an adult cut open the opposite end of the container so both sides are open in a hollow cylinder. Differently shaped containers will create different sizes and shapes of paper, so experiment with variations if you'd like. Find a sponge that is flat and even. The bigger, the better. Place a small, damp piece of cloth, like a quilting fabric, on top of your sponge. This will help you lift off your wet paper after it's cast. Align your hollow container on the cloth-covered sponge and press down on it to compress the sponge. Pour a little bit of your slurry into the open end of the container and slowly release the pressure off the sponge. This action creates a mild suction that absorbs most of the water from your slurry and leaves the wet paper fibers on the cloth. Cover the wet paper with another damp piece of cloth and gently remove the whole package from the sponge. Much of the water is already gone at this point, but the rest needs to be removed so the paper can dry and form those strong hydrogen bonds between the cellulose molecules. Place the cloth package in between dry tea towels or something else absorbent and put a light weight on top, like a cutting board or a thick book. Leave the whole stack for at least a few hours to dry. After a while, and if it looks like the paper wants to separate from your cloth, you can take it out and air dry the paper the rest of the way. And voila! You just made a small sheet of your very own paper. Try writing a tiny note for your sibling or caregiver, making a collage, or create a mobile of different shapes and colors. So, how do paper conservators use a similar technique in their practice? Sometimes works of art on paper get badly torn and entire portions of the paper are lost. Conservators can choose to fill these losses with another piece of carefully selected paper that is compatible with the object, or they can create their own custom papers. Custom pulp slurries can be created to match the fiber content and color of the artwork. The pulp can either be cast into dry coupons of paper like the ones you just made, or if the artwork can withstand exposure to moisture, the pulp can be cast into the artwork's losses while it's damp. This technique, called wet pulp filling, actually creates new paper around the existing paper using the same principle of hydrogen bonding to adhere the new pulp fibers to the edge of the loss. No adhesive is used in this technique, just the magic of science. Thank you all so much for joining me today. I hope you enjoyed this fun activity and learning all about the science behind paper making. If you make this project, we would love to see it, so have an adult post it to social media and tag @LACMA.